Welcome to We Learn online class. Today we are starting the subject operating system. First we will cover following topics: introduction to operating system, goals of an operating system, generations, in which generation which kind of operating system we used and going to be changed generation by generation, types of operating system, then desirable qualities of operating system. Now come to the topics. First, operating system. Operating system acts as an interface between the user and the hardware devices. Operating system works as a driver, as like a driver can drive the vehicle or anything by considering the number of objects or carrying the number of objects. Same way, the operating system works for the user and the hardware devices and works as an interface between the user and the hardware devices. A user can interact with operating system for providing some request, for getting some input, for getting some output. All and everything is done with the help of some operating system. If user want to access some resources, if user want to access some particular applications, then operating system help to user how to interact with the devices by providing some shortcuts, softwares. All of these help as user to how to interact with the hardware devices. Hardware devices are the physical machines or physical assets of the machine CPU which work together for achieving a common goal. Same way, operating system providing the support to hardware devices to make interactive for the user. By that way, user can interact with the system, with the devices, everything all. Like an operating system is software that manages computer hardware and software resources and provides common services for computer program. Like it provides the common services, computer programs, common platform, common interface for user and for hardware devices which are attached with the operating system, hardware devices which are works together for achieving a common task by the use of operating system. The operating system is an essential component of the system software in a computer system. Application program usually require an operating system to function. Number of applications you can install on your system, on your PC after installing the operating system. You can first install the operating system on your hardware device, then you can go further for another applications. Without operating system, you are not able to interact with the hardware devices directly or indirectly. First of all, you have to install the operating system in any device which is interactive with the user. It can be mobile device, it can be PDA, it can be any other device. That is all required kind of operating system which help them to interact with the user, and the user needs some external task to perform on that device. It requires some kind of different application software. Here we can differentiate two kinds of software. There is the system software and application software. System software are those software which are required for make interactive the hardware devices or make interactive for the user to work on the hardware device, on the machine, etc. Application software are those software which are installed by the user according to their requirement, according to their needs, according to the execution of required task. Any task which is need to be executed with that requirement of the customer, they need to install a particular software. Now this is the architecture, or you can say the layering architecture or layering step procedure, how user interact with the hardware. First level, user is there which request for some application and giving some command to application getting the response from the operating system and then provide the response to the user. But at the lower level, every request coming from the user is processed between the application and operating system, then hardware level. Then it perform or giving some result, giving some response in request of the in respect of the request from the generating user. they are getting the some responses at the same level. Request generated by the user pass on to the application, or you can say any task which is performing by a particular application software, that again pass to the operating system, which is working as an interface between the user and application with hardware devices. That operating system process that kind of request which is generated by the user and forward to the further levels like hardware system and any other devices for which we are giving some command. For example, we are giving the command like printing a paper from a system, a operating system, an application software and a user. These three levels or layers will work together, then we can get the results as an output from the printer. User giving some command for printing like control P, that is accepted by a printer software for a particular command for number of pages, that is accepted by printer software which is installed in the operating system or system as an application software. That request processed by the operating system and transferred to the printer for generating the or for giving the some printouts on the device. That is whole process is comes into the operating system interface, active participation on the results generation, accepting the request from the user, generating the results at the hardware level, at application level, etc. I think is that much clear. Now come to the next topic, abstract view of operating system. If we are going to be discuss abstract view of operating system, there is three layers where user interact layer by layer. Number of n users are there. At first level user interact with the compiler, second assembler, third text editor, next n number of applications can be there and n number of user can interact with that applications. These all are supported by the application programs, as like we have the number of application software in our system, then n number of user can access this system by using some technical resources, some technical aspects, some logical multiprocessing system, multiprogramming system that help them to access multiple data, multiple applications by providing a single operating system. As similar system and application programs are there. At the next level we are looking operating system is there. Operating system accepting the request, accepting the commands, accepting the kind of request for the applications for the particular task from the end user and generating the results and performing the accordingly which request coming from the user accordingly at the hardware level. Suppose we are giving command to shut down the system like Alt F4 and closing all the application, all that work or that kind of task is performed by the operating system, accepting the input, accepting the request from the user and performing on the operating system, and same command is transferred to the hardware devices, all the devices getting shut down at the same time when we are giving these kind of commands. This is the abstract view of our system. Now come to the next. Goals of operating system. Every task and every application have some goals or used for particular task, used for particular implementation, for achieving some kind of task, for achieving some kind of results. So goals of operating system are: the primary goal of an operating system is to make the computer convenient to use. Any device cannot work without any operating system, without any applications software. If we are having some device like mobile phone, if it doesn't have any operating system, it doesn't have any software, then it is kind of a physical dump machine, physical dump device. We cannot interact with that device. Like for example, switch off mobile phone is like a device which doesn't have and in which operating system is not working at the same time. That is kind of inconvenient to use. We are not able to make call, we are not able to make sending message and receiving message or getting internet connectivity, all that. So the operating system is to make the computer convenient to use. Same manner, a device is not able to interact with the user, or we can say a user cannot interact with the device if there is any other operating system. Like our computer system, if we are not installing any window, then how we can interact with that? We just buying the different number of parts of computer from the computer shop or any market and assemble them. Without installing operating system, we are not able to interact with that particular system. So primary goal of an operating system is to make the computer convenient to use. Accordingly, if we install any operating system on the hardware or any PC, then we installing some other applications also, we can say application softwares also, which are required by me, which are required by any user. Second goal is, the secondary goal is to use the hardware in an efficient manner. First, to make the computer convenient to use, and the secondary goal is to use the hardware in an efficient manner, not only to make it convenient to use. In efficient manner, like a P4 system, we are not able to install, or we can install Windows 8 and Windows Vista on P4 system, but it will not perform according to our expectation, because the configuration it has not supportable, or it is not able to perform accordingly. So we have the some configuration which support the kind of operating system that's help to use hardware device in efficient manner. Like we have 1 GB memory card in our mobile device, and we are going to be installing number of applications in that going to be installed. Then our time will come, then it is not allowed to install an application. So in that manner, it is not able to efficiently used as a hardware, as a physical device, as a mobile. These two goals are achieved by operating system, and we want to achieve these two goals by using some operating system. Okay, I think goals are clear to you. Goals, definition of operating system. Okay, good. Now come to next. History of operating system. Like we have the generations in computer system that comes 1945 and 1955. In that generation, we have a large size vacuum tubes and very much large size of our computer system, which required a large space to install, and taking so much time for starting the operating system, starting the computer, and generating loads of heat. We require a number of AC, number of cooling system for working it efficiently without any heating constraints. This is the first generation computer which performed their task. In the second generation, that is 1955 to 1965, there is vacuum tubes converted into transistors, and we have the batch systems in which similar types of tasks we can execute by making some batch simultaneously. At the same time, multiple tasks can be executed, but all the tasks have their group of similar execution or similar kind of task. In the third generation, our transistors converted into the ICs, and batch system comes into the multi-programming. Now we are going to execute multiple tasks simultaneously on the same system, and the all memory storage, all processing is done inside the ICs, and data stored in the number of chipsets, like in current generation. But current generation is storing the data in the very small memory size devices and microchip sizes, but in ICs there is a size comparatively very large, but it is not as much large right now. We are getting around 500 GB hard disk in normal computers, but at that time we are getting the 40 GB, 20 GB hard disk in third generations. In fourth generation we are using current computers like personal computers. They are almost having dual core processor and i3 processors we have, and large amount of disk space for storing the data or content. These are our generation and history of operating system, which day by day getting the much support from the hardware devices, and the devices will getting much small in size and much efficient in performing the multiple tasks simultaneously and supportable of multitasking, multi-programming, all that. Now come to the history of operating system with diagram form. This is our kind of representation for history of operating system. In this we store the data. Card reader is used for reading the cards, and that's data stored in the tape drive, like we in previous years used the cassettes for listening the songs and all that. Now we recently used input tape as same disk, which are having the coated of carbon coated or black coated screen or black tapes, which we used for storing the data, storing the content. Now in today we have the disk like hard disk, which have the black coated disk which have content, and we are getting the output as a printer and from the printer. These are the generation gaps which day by day increasing in the efficiency and increasing in the content generation. Now come into the next early batch system, like bring cards to 1401. This is the A portions. First we store the content in the cards form, then that card should be inserted in the card reader, and that data will be right on the disk, and that disk will be readable in 7094, and that 7094 content written disk we used for printing the commands, like we are getting the physical output. So this is a process. 1401 data is in cards that will insert into the card reader and converted into the disk form. Read card to tape on that tape, and then these tapes will generating in number of storing devices and number of copies. Then we are getting the number of disk, and these disks used for generating the physical hard copy printouts, like 7094 which does computing, calculating, and put tape on 1401 which prints output like this. It generating the physical outputs or physical copy for us. Now come to the next this process. This is the commands sequence, like we have in previous years Fortran language for generating the commands, for giving the instructions to the hardware devices. This Fortran syntax is written, and then this written the programs that will load for the execution and for the process that will run. If it run, then generate the data for program. This data will used by the us for generating the outputs, so for generating the results, or for processing the further task or performing the further task. This process is followed by the previous years by programmers or by the users who know how to work on Fortran language or other previous languages which is used in previous years by our previous programmers. Now come to the next structure of typical FMS job. सेकंड जनरेशन के अंदर सेम प्रोसेस फॉलो करते थे. Now history of operating system. This is our history in the form of operating system. Memory partition in current operating system or in the previous years we done in multiple disk, like we are having the 160 GB hard disk. We partition that disk in number of blocks or number of drives, job 1, job 2, job 3. These number of jobs will store in the number of drives, and single operating system will perform all the tasks on these jobs. This is a multi-programming system which allows to execute multiple tasks at the same system by using a single operating system. 3 jobs in memory in third generation, or it can be more. Like these are the types of operating system which used in the previous years or which are using we nowadays in a more efficiently, in a more better manner. First, batch processing operating system is like you can say a class is conducting by a person, and the class is for the BCA first semester, and all the students are able for attending that class for the same subject for the same time. That is a kind of batch. We can say BCA first semester batch. Batch means similar kind of jobs are collecting and making group for execution and input that group for execution process. Batch is a kind of collection of tasks which are same characteristic, same kind of, and we input for the operating system for execution and getting some output. That is the batch processing operating system. Yes, this one first. This is batch processing operating system. Next is real-time operating system. In real-time operating system, there is two types of real-time operating system. First is hard real-time system, and second is soft real-time system. Hard real-time system commits to execute your task on time and will complete surely. But soft real-time system only commit to complete your task but not commit for the time, how much time it will take for completion your execution. This is the real-time operating systems. Now come to the time sharing operating system. In time sharing operating system, we input the number of tasks, you can say job 1, job 2, job 3 into the system, and we allocate the time slots, all of them, for execution their task, for execution their process. After completion their process, or after completion their process, they will leave the queue, or before completion their time. If time complete, then the time will allocate it to the next process and it will switch on to the next if time quantum is there. So in time sharing system, a fixed time constants we have and number of jobs we have. At fixed time slot is allocated to every job, and after that time is completed, the time slot is given to the another task. Is that clear? Okay. Now come to the time sharing system is clear. Now come to the next, that is multi-programming operating system. In this we can do the multiple programs at the same time. Multiple programming can do multiple tasks at the same time, like we are copying some content from pen drive or from hard disk to another process, and same time we are doing or executing some another task. That is the multi-programming operating system. In multi-processing operating system, we have n number of processors which support to execute or which support to users to execute multiple tasks at the same time on the same system, but it is having n number of interfaces. For example, n computing systems. In this computing system, there is a single CPU which contains the multiple processors and providing support n number of users and all n number of users working independently on their different processors. That is a multiprocessing operating system. In multiprocessing operating system, if any main system, suppose there is a 4 system A, B, C, D. A is the master computer which is need to be start before working on the B, C, D computer. That is the main N computing system which providing the multiple processor support to access multiple users on the same system, but all of them are having n number of processor for executing their task. Now next one is network operating system, that is we can say NT operating system or NT window is a short name. You listen or read anywhere. That is a NT operating system, network operating system, that is specifically have some feature for establishing the network, for generating the number of user, for providing the multiple user to access the support, or providing the access at the same network with a single operating system but multiple processors. Distributed operating system. A single operating system is similar. Distributed operating system you can say as similar to multiprocessing system in some manner. In multiprocessing system we have a number of processor for providing the access, a number of user or who executing a number of tasks, but there is some difference. In multiprocessing system a single user can have a number of tasks which executed on a number of processors, but in distributed operating system a number of user can access on n number of computer and executing n number of tasks, but all are independently working. That is distributed operating system. Now we come on the next type of operating system, that is embedded, which embed the new devices or attach the new devices and providing the kind of support with other devices to use or to apply on the different applications and application softwares which require some different application like a webcam. Webcam is a kind of another device. If webcam is installed or physically installed on my system, on my monitor, then we required a software, we required an application for it embed with my operating system for working or for operating or for using. Is that clear? Now all kind of operating system we are discussing in detail. The first come batch processing system. If there is any named outcome, then you can discuss. In a batch processing operating system, environment user submit jobs to a central place. Batch processing system, all jobs should be similar types and should be inputted in a central place where these jobs are collected into a batch and subsequently placed on an input queue at the computer where they will run the task, execute the task. In this case, the user has no interaction. All the operations, all the processing, all the selection, inputting, outputting, selection of execution will done by the machine automatically. That will we work only providing the jobs to operator, and these operator make the batches which are similar in kinds jobs, and that will inputted to computer for execution. Now real-time system, there is the two type of real-time system. Real-time operating system is an operating system intended to serve real-time application process data as it comes in, typically without buffering delay. Means it doesn't take in lots of time or so much time for buffering the data or for processing the data, for generating the results. We are having two types of real-time system as I discussed before: hard real-time system and soft real-time system. There is some more constraints are there. Hard real-time system guarantee that critical tasks complete on time, as I discussed with you. In hard real-time systems, storage is limited or missing with data stored in ROM. In these systems, virtual memory is almost never found. Hard real-time system doesn't have the virtual memory. In soft real-time system are less restrictive. Critical real-time task gets priority over other tasks. Like other tasks, it will not provide any commitment to other tasks to complete on time. It just complete that task but not commitment to completion time about the execution or completion of the task in soft real-time system. Now this is the diagrammatical form of real-time system. Real-time operating system: robot program 1, robot program 2, robot program n. N number of robot programs can be there. Real-time battle gamer, it is the operator. They will provide the jobs, it will making the jobs in a batch and inputting for the execution. Now this simulation server will take decision which kind of task for the hard real-time system and which kind of task for the soft real-time system. Now come to the next: time sharing operating system. Provide advantages of quick response. Reduce CPU idle time. If there is a time slot allocated to a job, like 15 minutes, and that will complete it in 12 minutes, then 3 minutes get wasted. But in time sharing operating system, the jobs get switched out and switching with one to next to next till the whole jobs will be completed. Disadvantages of time sharing operating system are problem of reliability, question of security and integrity of user programs and data, problem of data communication, because there is not any communication, because we just input the jobs to the system and that will allocated the time slot and will execute by switching between all the jobs or available jobs, and at last it will complete the jobs, then give the results. You can see this is active link, this is CPU, n number of users are there, and this is our CPU. Jobs will executing all of the users by switching between first allocating to this, then switch to this, 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 and this is the representation. This job is completed. In the next process, this is not considerable, will continue from user 1, user 2, user 3, user 4 and to jump to user 6 task. That is the active link. Active link is the last link which acknowledges to the first user you are going to be start from beginning. Now, multi-programming operating system. A multi-programming operating system is one that allows end user to run more than one program at a time. Like a single user running this number of programs, program A run and waiting process is there, some waiting time is there, run, then again wait. Program B in the free time slot, putting their content, executing, waiting time is there is no collision, it will complete here, and now at the same time the next process is getting started here. There is no collision between them. In the same time, program C is going to be start, there is no collision between them. They are searching the free slots for execution their task. If we combine all of them at the last level, and it gives the time slots A, B, C, there is no any collision. At the same time, A, B, C, there is no any collision. This is the multi-programming operating system. A single CPU is working for all of the programs and executing all of the programs at the same time without any collision of task, without any delay of task. This waiting process is ideal of the system, but multi-programming reduce the ideal or reduce the waiting time of the process and reduce the wastage of resources, because all the task is adjusted between the free time slot. This is also multi-processing operating system, and this one is multi-programming. In multi-processing system, n number of users are there, n number of CPUs are there, but they are controlling with the single input output. This is, you can say, asymmetric processing, and this is a symmetric processing. In symmetric processing, every user is having their separate CPU and working together. In asymmetric multiprocessing, there is the single CPU control all of the users and providing the time slots and providing the content for executing and controlling all the system. If this system will get dumped, all the system is not able to work. In this, a single system will get dumped, the all system can work easily or efficiently. The one system effect cannot be affected to another systems. Now come to the distributed operating system. Use multiple central processor to serve multiple real-time applications and multiple users. Distributed system, as its name implies, distributed environment and distributed area. Like one system is located A place, second system is located B place, third system is located C place. They work efficiently for performing or executing a task. Distributed system use multiple central processor to serve multiple real-time application and multiple users which are located in A, B, C area or locations. Data processing jobs are distributed among the processors accordingly to which one can perform each job most efficiently. number of processors are there, and everyone is busy for execution of their task, and they are looking for which perform job most efficiently. Now the advantages of distributed system: with the resource sharing facility, user at one site may be able to use the resource available at another. A single person can share the resource which is located or which is used by another person at the another location. Speed up the exchange of data with one another via electronic mail. We can exchange our data or information using email system. If one site fails in a distributed system, the remaining sites can potentially continue operating. There is no effect if one system get dumped. If one system get failed, then other system will continue smoothly and working smoothly. There is not any kind of effect. Next, better service to the customers. It provides a better service because it is not a central system. A central system get much slow if number of user is accessing the simultaneously, like a university result is getting out and number of users, number of student accessing the same content on the same website, then website get low or website get slow down. But in distributed operating system, this kind of problem will not occur because it has a number of operating system, number of locations. Then if one system gets slow, then other will contribute their workload or their load of execution the process. Now come to the next, distributed operating system. In distributed operating system, number of machines attached with network, but they use distributed applications commonly. Like they all are having independent kernel. You can I think you can say kernel is work as an operating system or work like an operating system at every level. Then distributed operating system services will share the all machines, and in network operating system, in distributed applications, all machines have their independent networks at this level, at middle level after the kernel, and the last level is for the users, where the user get interacted with the devices, with the operating system, and sharing their data using some network. This is network operating system run on a server and provide server the capability to manage data, users, group, security, application and other networking functions. Everything is managed on the network very easily by using some network devices. The advantage of network operating system are following: centralized server are highly stable. There is a centralized server which control or which provide the all kind of support to all the clients, all the systems. Security is server managed. Security is managed by server for every client at itself also. Remote access to server is possible from different location and types of system. We can access the data which is stored on server from any location, but there should be a network connectivity is there. I think the third point is missing. Upgrade to new technologies and hardwares can be easily integrated into the system. In network operating system, we can attach the number of devices at number of locations to upgrade the technology, upgrade the hardware, upgrading the efficiency of the network. The disadvantage of network operating system are following. First, high cost of buying and running a server. To establishing a network, we required, I told you, required number of network devices. The first is buying the running server. Server is very much costly for establishing in a particular network. Dependency on a central location for most operations. Lots of operations or kind of operations are there which can performed and which can controlled only by the server, that is the central location. Regular maintenance and updates are required because a number of devices are connecting with the server and it required regularly to maintain all the system all the system works properly and their network is established properly for providing the accessing at server level. Now come to the next topic. Next is network operating system. Same before. In this there is a two differences are given. This one is peer-to-peer and this one is dedicated server. Peer-to-peer mention Windows for work groups network light. This is peer-to-peer network where every system is connected on the network and there is a very limited number of computers. You can say peer-to-peer is also where the two systems are connecting together, but a MAC address device is connected between them which control all of these two devices. And dedicated server is there where a single server control both PCs or n number of PCs. That is dedicated for providing the support all these number of devices. In this there is not any one is server but MAC controlling machine is there who control this peer-to-peer network but cannot work as a server. And server is dedicated for providing the services to the number of clients or number of devices which are directly attached on its network. Now come to the next. Desirable qualities of operating system. These are the desirable qualities. First one is usability. Usability means first robustness. It can perform their task in worst or in against the conditions. Second, accept all valid input and can handle them. It can accept only valid input. By valid input, our mean by valid input is like we have to generate counting till 100 numbers from 1 to 100. Suppose we are giving input for initial point is 1. It will giving output till 100. We are giving input 2. It will giving output 2 to 100. This is not a valid input. Valid input is that we require counting or number of counting from 1 to 100. We provide 1, then it will give counting till 100. This is the valid input. If we are giving 5, it is giving 5 to 100 counting. This is not a valid input. So, in desirable qualities of operating system, valid input should be there. It should perform only valid result, only valid result for valid input. If a system or any operating system or any software giving output on valid input, valid output, invalid input, same valid output, it means it compromising and having some loophole where its code is compromising with the content, compromising with the coding, compromising with the logical problem. So accept all valid input and can handle them. It can accept all valid input. You must specify what is valid input in examination or where you discuss, because valid input, there is some lots of meaning in software engineering about valid input. Now come to the consistency. It should perform the task or execution at the same efficiency or taking same time for executing a complex task, critical task or a normal task. If it is taking the same time for everything, that representing its consistency, it is performing consistently on the same execution time or taking same execution time. Proportionality, how much proportion, how much ratio is there for generating the output. If we are providing 100 input and it is giving around 200 outputs, then the ratio is 100 is to 200. 100 is an input and 200 is an output. Now convenience, which we discussed earlier as convenient to use, in that user is able or user can interact easily without any hurdles with system, with any device. That is convenience. as like I am accessing any operating system, but I am not able to understand their shortcuts and their keys number of options, like I am using Windows 7. It is as similar to Windows XE, but I am going to be using Windows 8.1. Then it is not convenient for me. So convenience which makes easy to use for the user, and which makes easier environment to user to interact with the device, to interact with the operating system. Last one is powerful with high level facilities. It should be powerful for executing, for accepting, for generating results, for processing facilities, and as compared to costs, want low cost and efficient services. These are the desirable qualities for any operating system. We want to use any operating system or any device at low cost, and it should provide efficient services. Low overhead, cost of doing nothing should be low, idle time at a terminal. Next one, low maintenance cost, system should not require constant attention. All the points are clear? Any query? Now come to the next slide. This is continue with the previous one. In this we discuss the facilities and adaptability of the operating system. In facilities, the first point, sufficient for intended use. We require the number of devices, we require the number of resources by operating system which provide me or provide a user a comfortable environment where it can interact or it can perform any task easily or comfortably. Next point is complete. Any number of resources or n number of resources is available in operating system or application software, but if any resource is not doing their task completely, but it is able to do the task but not able to do everything, like conversion a PDF file into Word. Suppose we have the software, it is able to convert the PDF file into Word, but it is not able to convert images also into Word format. A content or a file we have in a PDF format which have some text and images also, but when we converting that PDF file into Word format or into Word file, then images are not coming there, only text is converting into Word file. This is not complete. So we require a kind of resource or kind of application or kind of software which do the complete task. And the last one is appropriate. We can understand an operating system. Appropriate means we are giving some output, we are giving some command to a system. It is accepting and doing some task impartially, not completely. So we require the appropriate software for execution or for completion the task. As I discussed the example, conversion of PDF to Word, like it is not doing the complete tasks, then we require the appropriate software which can convert the PDF format or PDF content into Word, including the image as well as text, both of them. Same. Now we are coming to adaptability, which is easily adapt the new things and easily allow new installation of new devices in our system, like changeable over time, adapt as needs and resources change, expanding memory and new devices or new user population. Extendable, adding new facilities and features which look like the old ones, means extend or add on some new features to the existing one. Now come to the next examples of operating system. These are the examples of operating system. First, DOS, disk operating system, was the first widely installed operating system for personal computers. It is a master control program that is automatically run when you start your personal computer. When we switch on our computer power button or a switch button, then it automatically call or execute the number of commands, number of files, or verifying number of files, or executing number of commands. That is the disk operating system DOS prompt. Like you can check out after the class. Start the system, there is the black screen will come. It will check file by file and check to update the system. These all come into the DOS operating system and other operating system also. Like older versions, we have the DOS operating system and Unix operating system are used in widely sold workstation product from Sun Microsystem, like Silicon Graphics, IBM, and a number of other companies of operating systems are there. Unix is written in C language. Both Unix and C were developed by AT&T Bell Laboratory and freely distributed to government and academic institutions for classes and for operations, but it is not permissible to use commercially or for professional or for earning purpose. The major shells are the Bourne shell and C shell, Cone shell. These are the shells which accept the commands from the user and perform accordingly or help to work on the operating systems. Come to the next examples. Windows is a personal computer operating system from Microsoft. Windows contain built-in networking which allows users to share files and application with each other if their PC are connected to a network. It is also having the sharing capability of data and content, but PC should be physically connected with other system, or it has some Bluetooth or other devices, physical devices for establishment of the network. Next one is Macintosh, often called the Mac, introduced in 1984 by Apple Computer, was the first widely sold personal computer with a graphical user interface and its own operating system. Mac operating system, which in its latest version is called Mac OS X. The Mac was designed to provide user with a natural, intuitively understandable and in general user-friendly computer interface which help them to work or to achieve their task, to execute their task on the same manner as the previous version of operating system with the high efficiency or execution time. These are the functions of operating system. First, process management, like number of processes are executing in a single system simultaneously. It needs to be managed all the processes, like we are writing a CD, we are copying some content from system to a pen drive, and we are doing some programming task or executing a program, and lots of many programs may be there. All are managed by the operating system. Next one is memory management. This task is also done by the operating system. In management form, it clear the buffered data or temporary files when required for maintaining the execution speed. In some system, it can be required to do this task manually, but memory management task is also done by the operating system when it is required, and when the buffer is full, then it will require to restart the operating system for deleting or removing the temporary files from the buffer. Then next is secondary storage management. Secondary storage management is the storage of the data permanently on the hard disk, and we can say that content is stored in a non-volatile form in the system, which is not removed or deleted whenever the system is failure or whenever the system is get restarted. The content is removed or not recovered, which is stored in the volatile form. Volatile is temporary storage and non-volatile is permanent storage. In non-volatile the physical devices are come. Volatile is logical or cache memory store or provide the support to hold that kind of content. Next one is input output management. It takes input by the keyboard, mouse, and generating output in the form of monitor or on the desktop, and if we are giving some command, it can generate that kind of output on physical copy by the printers. Next one is file management. File management is a kind of task which is very much important in operating system. Like we are doing number of tasks and storing that content into number of files, like Word file, image file, PowerPoint file, number of files, and these files are allocated a memory space in a contiguous manner or in a discrete way. Contiguous means the content is started and we know it will continue till the end, and we know the initial and ending point in a contiguous memory allocation process. It is different from continuous. There is a two terms which are similar, but there is lots of difference. In contiguous, we know the initial and ending, both points, but in continuous process, we know only the initial time or initial point, but we don't know about the ending point or ending time of the process. So that is also managed by the operating system. Now protection. It provides the protection for accessing the system by providing the kind of user creation process. We can create a number of user on our system, like guest user, admin user, client user. We can create number of user, and we can also provide the number of access rights to all of them. By using this, we can provide the protection to our system or our content on the system. Next one is network management. By connecting the system to a network for sharing the data and information, a network system is required a kind of firewall or antiviruses for protecting the system content, for protecting the unauthorized or intruders to enter our system. Next one is command interpretation. It accepts the commands from the user on their DOS prompt on CMD and perform their task accordingly in respect of the user commands. Now come to the next topic, which is functions of operating system. These all functions are performed by the operating system. Let's start from the input-output management, which we discussed, protection and security, file management, secondary storage, memory management, networking, user interface. That is the focused topic of this subject, operating system. Operating system, as I told you, the operating system is an interface and provide an kind of interface where user can interact easily with their hardware devices. Communication management, when a single computer connecting with other computer for sharing data, or we can say when a single computer generating some kind of command for printing the data, for printing the commands, for printing the results. Like a single system is connected with the printer, and printer giving some command to printer, and printer generating the physical hard copy outputs or giving printouts. This is the communication between the computer system and printer. Like process management, I think all topics we discussed. Now come to the next functions of operating system. These are in more details. Process management. Operating system is responsible for the following activities. The first one is the creation and deletion of both user and system process. Next, the suspension and resumption of processes. Next, the provision of mechanism for process synchronization. The provision of mechanisms for deadlock handling. What is deadlock? Deadlock is a situation when system get hang out or it is not able to provide any support or not responding to user. In deadlock condition, there is the 4 conditions which are the causes of deadlock. When these 4 conditions comes simultaneously or existing at the same time, then we can say deadlock is occurred. Deadlock means hanging out of process, or it is not responding for any task or any command. That is a deadlock. And the conditions of deadlock are: first, hold and wait. In hold and wait, there is a single process is holding number of resources, like there is P1, P2 and P3. 3 processes are there. P1 holding R1 resource, P2 holding R2 resource and P3 holding R3 resource. P representing process and R representing resources. P1 process holding R1 resource, P2 process holding R2 resource, P3 process holding R3 resource. If all of them generating request for the next resource which is holded by the another process and not releasing the existing resource which are held by them, then this is the one of them condition which is the cause of deadlock. In this process, P1 requesting for R2 resource, P2 requesting for R3 resource, P3 requesting for R1 resource, and all the resources are held by the another processes. They are requesting for another process but not releasing the existing process. If this kind of condition arises, then it may cause the deadlock. This is the condition for hold and wait. Holding a resource and waiting for another resource. Next is kind of condition like there is 3 resources already in our example, but in the next example, if circular manner, we have the n number of processes and all of them holding the n number of resources and requesting for another resources without releasing existing resources. That is the circular waiting condition for deadlock. And the next condition is we discussed hold and wait, circular wait. Next one is no permission. In this, a single process holding R1 resource after completion their task but not releasing that resource, means it is not going to be released the particular resource without completing their task or after completing their task. This is kind of monopoly where a single process running a single resource but not releasing after request of another processes. This is no permission condition. So we discussed 3 conditions: hold and wait, circular wait, no permission, and the last one is we can hold and wait, circular waiting, no permission, and no releasing of the resources. No releasing of resources in which nobody is ready to back out. Now, synchronization is the solution of deadlock. These all undercomes inside the process management. This will come in detail in further classes because this is the complete chapter and a very big topic. Here is just an introduction about this. Now come to the memory management. The operating system is responsible for the following activities in connection with memory management. First, keep track of which part of memory are currently being used and by whom. It records or it creating offsets. Offset is known as an index. Which part of memory is used by which user. Next, decide which process are to be loaded into memory when memory space becomes available. It keep track of information about all that storing or retrieving, number of processing for execution, but which one is picked first for execution or process. The next one is allocate and deallocate memory space as needed. Whenever there is a requirement of allocation of resources, it will look out for the memory space which is free and which can be allocated, and whenever we require the memory space and there is no available space, then it will look out which can be released and which is not longer be used in future. That kind of memory space get released and used for allocation of new resources. Now we come to the next functions of operating system. First, secondary storage management. Secondary storage is physical storage, or we can say is a non-volatile storage, where our data is stored permanently till our choice or till the physical damage in the hard disk or system. Second, input-output management. The operating system is responsible for the following activities in connection to input-output management. First, a buffer caching system. Buffer is a temporary holding or providing the support for content which is displayed on the screen in any system at runtime or dynamic manner. Second, to activate a general device driver code. For every device which is connected with the system or which is connected or which is working on the operating system, it generates some code for that particular device. Or in the network system, we can say to allocate the MAC address to every particular device or client for accessing their data, for sharing their data and information. And the next point is to run the driver software for specific hardware devices as and when required. Is that clear? Now, the next one is file management. The operating system is responsible for the following activities in connection to the file management: the creation and deletion of files, the creation and deletion of directory, the support of primitive for manipulating files and directories, the mapping of files onto disk storage, mapping with the offset, or you can say index, with the stored data which is stored in particular locations in memory, and offset which is generated by the operating system for looking out the memory space, which one is allocated to which resources. Next is protection and security of the files. To provide the protection or security, we can apply the bit lock on the particular drive, or we can apply the BitLocker on particular files in Microsoft operating systems. It will provide us kind of protection or security on particular files. Now, next one is protection. Protection refers to a mechanism for controlling the access of programs, processes, users to the resources defined by a computer, control to be imposed together with some means of enforcement. It is also concerning with the providing security or providing security against the unauthorized access, unauthorizing accessing the rights or files or content, etc. Protection can improve reliability by detecting latent errors at the interfaces between component and subsystems. Now come to the next functions of operating system. Networking. A distributed system provides the user with access to the various resources. The system maintains access to a shared resources. If there is network word or network term will come, then implicitly it call with the sharing of data, sharing of resources, sharing of content. Access to shared resources allows computation speed up, data availability and reliability. Next one is command interpretation. When performing task by using some commands, like we are working on the DOS operating system or Linux, by using commands we can perform every task same manner. One of the most important component of an operating system is its command interpreter. The command interpreter is the primary interface between the user and the rest of the system. Many commands are given to the operating system by control statements. The command statement themselves deal with process management like input-output, handling, secondary storage management, main memory management, file system protection and networking, which we discussed earlier. Now come to the next. That's all. Thank you so much. Now we are coming to the next unit.